Our next speaker is Dr. Jim Walker from Plant and Food Research, who leads the Pip Fruit Bioprotection Program. And he's led the team that has introduced semi-chemicals and biological controls to the apple industry, reducing pesticide use by over 90%. So today he's going to talk to us about sterile insects.
Thank you, Travis, and thank you for the opportunity to speak to you today. The title of my presentation is really Piloting Area-Wide Sterile Insect Releases of Codling Moth in New Zealand. So really just looking at some of the examples of the sterile insect technique internationally. Screwworm eradication in the US started back in 1962 and still operational today. Codling moth in British Columbia since 1992. The tsetse fly in South Africa. The false codling moth, fruit flies, tsetse flies in Africa, fruit flies in USA, Japan, South Africa, Israel, and more recently Australia, false codling moth in citrus in South Africa, and Aedes mosquito control recently with the Zika virus in South America. So really, the first use of SIT in New Zealand was with the painted apple moth program, and we all know how unpopular, I guess, the aerial spraying of 4A48K was over Auckland. But what it did achieve was reducing moth numbers by 99%. It was important to recognise that SIT was then used with an overflooding ratio to achieve that eradication as the final step in that eradication or elimination program. Now, SIT for the apple sector, and really here talking about a pilot program against codling moth. The economic case, the sector's goal really is for pest-free and residue-free fruit for 70-odd international markets. For many of our markets, there's a zero tolerance for codling moth, and particularly in the higher value emerging Asian markets. And the Asian market premiums to apple growers are worth an additional 20 to 50K per hectare to the bottom line. So if we think of SIT and its compatibility, codling moth SIT is a very pest-specific method. It's compatible with our current IPM practices, including mating disruption. There is potential for long-term suppression using the technique against codling moth. And it's possible to think of elimination of local populations, potentially even eradication. And this is really our justification for our use of it in a pilot program. So where are we getting our insects from? They come from the Okanagan Kootenay Sterile Insect Release Program in Canada. There the moths are irradiated. The treated moths are then released into orchards, mating with wild moths. Egg hatch is greatly reduced, but importantly, any F1 arising from those are sterile. We're starting with overflooding ratios in excess of 30 sterile insects to one wild moth, and as we progress towards further reduction in insect populations, so that overflooding ratio increases. So if we think now about Canadian moths and their summer holiday destination New Zealand, we have an MPI import permit. We have been importing up to 80,000 moths per week over the summer months. We've got a 30 to 35 hour transit time from Penticton in British Columbia to Hawke's Bay, New Zealand. And during that time, the adult moths are kept immobile at temperatures around 1 degree centigrade. So they're leaving in the middle of winter. We're using their winter production. They're spending their summer in New Zealand. These sterile moths are marked with red food dye, so we can tell the sterile moths apart from the wild moths. You can see the irradiation USDA APHIS sticker on the containers to show that they've been irradiated, that we're not releasing viable codling moth out there into our orchards. These moths live for some 2 to 3 weeks in the field. The release area that we're piloting the program in is on the Ruataniwha Plains. We started with just 200 hectares, but now have expanded to 350 hectares with these orchards on the northern side of the Waipawa River. It's an isolated production area, and the release rate is around 200 moths per hectare per week, and we're making some 10 to 12 releases per season. The releases are made using a GPS-guided UAV. It's a fixed-wing aircraft, 2.4 metre wingspan. And what this does allow, in the case of, say, a 100-hectare orchard, is very efficient delivery of the insects, controlled release, 20,000 moths in a single flight of about 10 minutes, and controlled release over that area. If we look at our pre-SIT orchard, one of the example orchards here, some of the features are a low codling moth population at the outset. This is pre-SIT on one of these orchards, some 50-odd pheromone traps across the orchard there. The orchard's using timed insecticide applications and combined with areas of mating disruption on the property. These are the individual trap catches, many of them quite low because of the mating disruption. But the season before SIT, the total wild catch of codling moth was just 103 moths. Release year 2, this is after 2 years of release, but it's just 1 year of the SIT effect because of the intergenerational delays. And the total catch of wild codling moth after 1 season of the SIT effect was a total of 16 moths caught and overflooding ratios exceeding well over 100 to 1. If we compare the northern group of orchards, 2015-16 versus over that 3-year period, and compare them with the SIT orchards, what we can see is in the SIT orchards is this reduction that we've achieved, around about an 87% lower catch of codling moth on the SIT orchards. Codling moth, SIT, ambitious or crazy? We have to think about the sector-wide opportunities. Just one codling moth in a carton of New Zealand apples can knock out an entire pathway. So it's not just the orchard, it's the packhouse, it's the exporter, and all of the growers using or involved with that supply group. So what we're talking about here is potentially freedom from that codling moth risk. The economic value, potentially $80 million per annum, rising as the industry's growth strategy increasingly targets Asia to more than $200 million per annum by 2022. Further reductions in insecticide use and residues is possible, and the current cost of the program is actually less than the cost of mating disruption. Some of the sector challenges that we face, if we move from the Ruataniwha to the Heratonga Plains, is sector support for an area-wide program. The elimination of alternate host plants. It's not necessarily elimination. There are a lot of walnut trees and that out there, so we've got to take these into consideration in terms of the whole program. So we need community engagement and support. We also need CAA approval for overflying urban areas. And we need to think about the acceptability of our insect rearing and sterilisation technology that we're currently using, that being irradiation, albeit offshore in Canada. But it's a very different landscape when we upscale the problem and the eradication program from what we're doing currently. So SIT is a biosecurity strategy. I say ambitious, perhaps not crazy, but if we think about the SIT program successes internationally, suppression and or eradication, undoubtedly various successes with lepidopteran insects, demonstrated success with the fruit flies. It is an effective technology. If we think really about brown marmorated stink bug and the future risks associated with that, we do know that early detection is unlikely. The use of neonicotinoid or pyrethroid insecticides is always going to be unacceptable in our urban and peri-urban areas. The samurai wasp, perhaps preparedness is a really appropriate strategy. At best, it might give us some suppression. SIT is still really an opportunity that's out there that is possibly on the table. It's never been demonstrated against a hemipteran pest, and therein lies some challenges around the irradiation biology. But BMSB eradication potentially using SIT is a new and potentially innovative approach. And I think for the magnitude and scale of what brown marmorated stink bug might mean for New Zealand, both the productive sector but also in our communities and urban environments, maybe it's worth the attempt. So I say it's ambitious. I don't think we could say it's crazy until we look at it. So with that, I'd just like to really acknowledge some of the contributors to the program. And with that, thank you very much.
Questions? One over here.
Yes.
Looking into the light.
Jim, just clarification. I was actually wondering about the Canadian production of moths, whether they were actually using moths themselves or whether they're just doing it specifically and specially for New Zealand as part of an experiment.
No, we're importing the moths specifically for this program. Is that the question that you're asking me? Yep. So it's a deliberate targeted program. The cost of those moths landed here in New Zealand works out to be somewhere around about $202 to $250 per hectare, which is currently about half the cost of mating disruption.
One here, and then the last one there.
Steve.
Jim, very interesting. Did you say one larva is enough to wreck a trade route?
Yes.
So would SIT be safe enough to risk that? I can see SIT is really good at suppressing pest populations, but is it really good enough to take that risk? Isn't Law's ban better, Jim?
You're not going to take me back there, Steve. No, what we're really doing here is adding, it's additive. It's all of these technologies. So we're using insecticides. Yeah. The whole idea is that if we can drive these local populations to the point of extinction, then codling moth is relatively immobile, and it'll be long periods before we get any recolonisation. So we're underpinning the whole program with SIT.
Very convincing, Jim. Thank you.
Last question.
Thanks, Jim. That's a great talk. It's really exciting to see hopefully an effective control to codling moth, which was the target of New Zealand's first biosecurity regulations in the 1890s, I think, the Codling Moth Act. My question is about you were apparently deploying these into areas where you were doing mating disruption and mass trapping as well, and obviously that's going to interfere with the efficacy of you'll be trapping and disrupting the moths that you're releasing. So why did you continue with those practices?
I guess it's really that we have no choice but to put this in as an additive technology to take the whole population down. I guess around our orchards, we're recognising that through this technique, we're subjected to immigration from these external sources. What we're doing here is releasing moths into that environment. They're also free to mate with those peripheral populations of codling moth that add risk to our whole program. So I see it as compatible and complementary and additive technology, slightly disruptive, potentially, but the insecticides that we use today are not adulticides. So these are larvicides, and we're reducing adults, introducing adults, sterile adults into that environment. So we're not killing them with the insecticides.
Oh, last one.
Yeah, just to follow up on your answer there, Jim. John, you had 350 hectares of apples there that is still in commercial production, and you have to meet export guidelines for the right to export that fruit. The science system cannot pay the compensation to dump that fruit. It still has to be exported, so you have to maintain what is accepted control technology while we're testing this technology. But Jim's right, it's a systems approach. We're putting it all together.
Yeah, the key point here is we're in a regulatory environment. It's a regulatory program through into these codling moth sensitive markets. We've got to stay within the MPI rules, and we're really working to enhance the outcome, not jeopardise it.
Yeah, so just to clarify, if you can show that it's effective with these other things going on, then it's going to be even more effective when you remove the mating disruption and the mass trapping, for example.
Only if we get to a point of elimination of the risk, at least locally, and can manage that in some way.
Yeah, if you can show that the SIT is enough to...
Yep.
All right, becoming a conversation, John. Thank you.